Hey everyone, welcome back to the channel. Today we are diving into data structures. This video will walk you through everything you need to know about data structures, how to create them, access elements, modify them, and much more. So let's get started. Python offers several built-in data structures such as lists, tuples, sets, and dictionaries. Each of these has unique properties and use cases. Let's cover them one by one. A list in Python is a data structure that allows you to store an ordered collection of items. These items can be of any type: integers, strings, floats, or even other lists. Lists are incredibly versatile and are used in almost every Python program. Some key features of lists are ordered. The elements in a list maintain the order in which they were added. Mutable. You can modify lists by adding, removing, or changing elements. Dynamic size. Lists can grow or shrink dynamically. There's no fixed size limit. Heterogeneous. A single list can store elements of different types, making them flexible and powerful. Alright, let's create some lists in Python. The simplest way is by using square brackets and separating elements with commas. Another way to create a list is by using the list constructor. This is useful when creating lists from tuples or other iterable objects. You can also create a list from a string. Each character of the string becomes a separate element in the list. Now that we have created lists, let's learn how to access their elements. You can use indexing to retrieve specific elements. Python uses a zero-based indexing, which means the first element has an index of 0, the second element 1, and so on. You can even index elements from the end of the list using a negative index value. -1 gives the last element in the list, and in general, -n gives the nth element from the end. This is called negative indexing. You can also use slicing to extract a range of elements. Loops are a great way to iterate over lists. The simplest method is using a for loop. If you also need to index while iterating, use the enumerate method. List comprehensions are another powerful way to filter or manipulate lists in a single line. Here's an example of extracting countries that start with the letter I. Lists can contain other lists. This is useful for organizing related data. Lists are mutable, meaning you can modify them by adding or removing elements. To add an element, use the append method. To add multiple elements, use the extend method. To insert an element at a specific position, use the insert method. And to remove elements, use the remove or pop method. One of the most common operations when working with lists is finding the position of an element. In Python, we can use the index method to get the index of a specific item in the list. This will return 1 if Germany is in the list. However, if we try to find an element that does not exist in the list, it will raise a value error. To handle this error safely, we use the try except block. This will print Malaysia is not in the list instead of throwing an error, and more importantly, it does not stop the execution of the cell when the error is encountered. If you want to count how many times an element appears in a list, use the count method. When removing elements, the remove method deletes only the first occurrence of an element. To sort a list in ascending order, use the sort method. You can reverse a list using the reverse method. Alternatively, you can use slicing to achieve the same result. When assigning a list to another variable, both variables point to the same object in memory. The output shows that adding Malaysia to the copied list countries copy also affects the original list countries. To create an independent copy, use the copy method. To remove all elements from a list, use clear method. This empties the list completely. The next data structure we'll cover is tuples. Tuples in Python are ordered immutable collections of elements. They function similarly to lists but with one key difference. Once created, tuples value cannot be changed. This immutability makes tuples particularly useful when working with fixed data that should not be altered. Key features of tuples are ordered, elements retain their position in the tuple, immutable, cannot be modified after creation, heterogeneous, can store different data types, hashable, can be used as dictionary keys if they contain only hashable elements. To create a tuple in Python, you can enclose a comma-separated sequence of values within parentheses. Here's an example. You can also create a tuple without using parentheses, just by separating the values with commas. Similar to lists, tuples support accessing elements using indexes and slices. Functions like append and remove are not available for tuples since they're immutable. Tuples can be combined using the plus operator. Tuples can be repeated using the star operator. You can assign tuple elements to multiple variables in one step. Tuples are ideal when working with constant data such as geographic coordinates like latitude and longitude, or fixed configurations. Functions in Python can return multiple values as tuples, making them useful for returning grouped data. The next data structure we'll cover is called set. A set in Python is an unordered collection of unique elements. The key features of a set are they are unordered. Items in a set don't have a defined order. You cannot rely on the order of elements when you print or iterate through a set. Unique elements. Each element in a set is unique. If you try to add a duplicate, it's simply ignored. Mutable. Sets are mutable. You can add or remove elements after creation. And no indexing. Since sets are unordered, they do not support indexing, slicing, or other sequence-like behaviors. Sets are incredibly useful when you need to store distinct values and want to perform fast membership tests. Now let's see how to create a set in Python. Consider the following example. In this code, we are creating a set named countries. Notice that even though India appears twice in the curly braces, the set only keeps one copy because sets can only contain unique elements. When you print it, you will see something like this. Order may vary because sets are unordered. You can also create a set from other iterables such as lists using the set constructor. This will produce the same result. The duplicates are removed automatically. One of the primary benefits of sets is fast membership testing. You can quickly check if an element exists in a set using the in keyword. This prints true if India is in the set, and it's a very efficient operation. Next, let's look at how to modify sets by adding and removing elements. To add an element, you can use the add method. After running this code, countries will include China along with the other unique countries. When it comes to removing elements, there are two primary methods, remove and discard. The difference is that remove will raise a key error if the element is not found, whereas discard will do nothing if the element does not exist. To find out how many elements are in a set, you can use the built-in len function. This will print the number of unique elements in the country's set. Let's move on to some powerful set operations. Suppose we have two sets. The union of two sets is the set of all elements that are in either set. You can compute this using the pipe operator or the union method. Next, the intersection of two sets contains only elements present in both sets. Use the ampersand operator or the intersection method. The difference between two sets gives you the elements that are in the first set but not in the second set. It is computed with the minus operator or the difference method. Finally, the symmetric difference returns elements that are in either set but not in both. This can be computed using the caret operator or the symmetric difference method. Sets also allow you to perform subset and superset checks. For instance, consider the following sets. To check if one set is a subset of another, use the isSubset method. And to check if one set is a superset, use the isSuperset method. Additionally, you can check if two sets are disjoint, meaning they have no elements in common, using the isDisjoint method. In our example, set 1 and set 4 are disjoint because they have no elements in common. Python sets also support in-place update operations. These methods modify the original set rather than creating a new one. Let's explore a few common update operations. Update method adds all elements from another set or any iterable to the original set. Next, the intersection update method updates the set to contain only elements found in both sets. Similarly, the difference update method removes elements found in another set from the original set. Finally, the symmetric difference update method updates the set to the symmetric difference of itself and another set. Great. Now let's move on to dictionaries. In Python, a dictionary is a collection of changeable and indexed elements. Think of it like a real world dictionary where each word, which we'll call a key, is mapped to a definition or a value. Dictionaries are defined by using curly braces and contain key value pairs separated by a colon. In this example, we have created a dictionary called person with keys like name, age, and city. When you print it, you will see a similar output to what's defined. In Python, dictionaries used to be unordered before version 3.7. However, starting from Python 3.7, dictionaries maintain insertion order as an implementation detail. Accessing elements in a dictionary is straightforward. You can do this using the square bracket with the key or by using the get method. Let's see an example. Both of these methods will return the value associated with the key city, which in our case is Kolkata. The key difference is that using the get method is generally safe. It returns none if the key doesn't exist instead of raising an error. Dictionaries are mutable, meaning you can add new key value pairs or update existing ones after the dictionary has been created. For example, to add a new key value pair, simply assign a value to a new key. Now, person contains a new key gender with the value male. Similarly, updating a value is as simple as reassigning a key. Here we have updated the age from 30 to 31. Removing items from a dictionary can be done in a few ways. The first method is using the del keyword, which removes the key and its corresponding value. This removes the age key from our dictionary. Another way to remove a key value pair is by using the pop method. This method not only removes the specified key but also returns its value. After calling the pop method, the key gender is removed from the person dictionary. Dictionaries can also be nested. This means that a dictionary can hold another dictionary as its value. Let's look at an example where we maintain contacts with each contact's phone number and email stored in a nested dictionary. This nested structure is particularly useful for storing complex data such as contact information in a clear and organized way. Often you might want to iterate over a dictionary to process its keys, values, or both. Here's how you can do it. Using a simple for loop, you can iterate through each key. Keys method also returns a view of all keys in the dictionary. If you need the values, use the values method. And to iterate over both keys and values simultaneously, use the items method. This is especially useful when you want to format the output like displaying each contact's details. Dictionaries also offer additional methods for updating and removing key value pairs. Update method merges the provided dictionary into the existing one. In this example, we update the details for RM Roy and add a new contact IC Chatterjee. To remove specific key value pair, you can use pop method which returns the removed value. In this snippet, RM Roy is removed and his contact details are returned. Alternatively, the pop item method removes and returns the last inserted key value pair as a tuple. This is handy when you need to remove items in a last in first out manner. Lastly, let's talk about dictionary comprehensions, a concise way to create dictionaries. This is similar to list comprehensions but for key value pairs. For example, to create a dictionary of squares for numbers 1 through 5, we can use this code. This one-liner creates a dictionary where each key is a number and its corresponding value is a square of that number. Dictionary comprehensions are both powerful and elegant. Dictionaries are useful for mapping one value to another and are frequently used for tasks like counting the frequency of words in a text. Consider this example. In this code, we split the string into words and use a dictionary to count how many times each word occurs. The get method is used to provide a default value of 0 if a word isn't already in the dictionary. That wraps our deep dive into Python data structures. In this video, we explored lists, sets, tuples, and dictionaries. Together, these topics give you a comprehensive toolkit for handling data in Python. If you enjoyed this video, please give us a thumbs up, subscribe to the channel, and hit the bell icon so that you don't miss any of our incoming tutorials. If you have any questions or suggestions, drop them in the comments below, and I would love to hear your thoughts. Thanks for watching and happy coding.